This video we're going to look at fractional arithmetic. We're going to start with multiplication as it's the easiest. When it comes to multiplying, we just multiply the numerators and then multiply the denominators. When we're done, we can simplify. You notice in this example, both are divisible by 3. So 15 divided by 3 is 5, 24 divided by 3 is 8, and that's our final answer. In the second example, that 4 is the same as 4 over 1. Multiply the numerators. 4 times 5 is 20. 1 times 8 is 8. From there, both are divisible by 4. 20 divided by 4 is 5, and 8 divided by 4 is 2. Now this is in what we call an improper form, so we need to switch it to a mixed number for our final answer. So 5 halves is the same as 2 and 1 half. 2 goes into 5 2 times with 1 remainder. Our last example has mixed numbers, so we need to switch them to improper before multiplying. So the first one becomes 16 over 3, and the second becomes 13 over 6. When we multiply, this becomes 208 over 18. Both are divisible by 2, giving us 104 over 9. And then 9 goes into 104 11 times with a remainder of 5. Now let's take some time to look at division. Division's almost as easy as multiplication. The first step is to switch it to multiplication. Division becomes multiplication, and we flip or invert the second fraction. Then we get 7 times 2 is 14, 8 times 1 is 8. Both are divisible by 2, so we get 7 quarters, which is the same as 1 and 3 quarters. The second example, this is the same as 7 ninths divided by 6 over 1. So 7 over 9 times 1 over 6. Remember, and flip the second fraction, change it to multiplication. We now get 7 over 54, which doesn't reduce, so we are done. The last example has a mixed number. This becomes 22 over 5 divided by 2/3. Remember to switch any mixed numbers to improper fractions before doing to the next step. The next step is the invert and multiply. So flip the second fraction and multiply. This becomes 66 over 10, which is the same as 33 over 5, or 3 3/5. Now let's look at some addition and subtraction. With addition and subtraction, it's all about a common denominator. In the first example, we have 3 quarters and a half. The common denominator between 4 and 2 is just 4. Yes, you could use 8, which is 2 times 4, but it's always best to use the lowest. You'll find it's less work in the long run. So the first fraction stays the same. The second fraction, in order to get a 4, we'd have to times the bottom by 2. If we times the bottom by 2, we have to times the top by 2. So 1 half is the same as 2 quarters. Adding them together, we get 5 over 4. We just add the numerators, the denominator stays the same. Often with fractions like this, think money. If you had 3 quarters and 2 quarters, you have 5 quarters. Okay, 5 quarters is the same as 1 1/4, or $1.25 if you will. Second example, we have 8 and 6 for our denominators. You could multiply them together, giving you 48, but the lowest is actually 24. So if we times top and bottom by 3 here, and this one by 4, we get 15 over 24 plus 4 over 24 for a final answer of 19 over 24. Now again, yes, you could have used 48, but then you would have had an extra step at the end of reduction, so it's always best to use that lowest common denominator. Subtraction is the same thing. This first example, the second fraction can become 2 over 6, just timesing top and bottom both by 2. 5 minus 2 is 3, denominator stays the same, then we can reduce to 1 half. In the second example, looking at the 9 and 6, the lowest common denominator is 18. To get 18 for the first one, we had to times 9 by 2, so we times the top by 2. In the second one, 6 times 3 is 18, so the top is 3. Subtracting, we get 5 over 18. The last several examples are adding and subtracting mixed numbers. Now there's a couple of schools of thought on this, but I'm going to show you the easier and the better way. When you're adding mixed numbers, leave them in mixed number form. First, find that common denominator. In this case, it'll be an 8. So you have the first fraction stays the same, and the second becomes 2 over 8 times in top and bottom by 2. Now that you've done that, we can add. Add your whole numbers. 2 plus 3 is 5. Add your fractions. 1 plus 2 is 3. The denominator stays the same. Now the second example really illustrates why we leave it in mixed number form. If you were to try and convert these to improper fractions, you're going to have very large numbers, and it's always easier to work with smaller numbers when you don't have a calculator. So we leave it as 7 3/4, and the second one becomes 12 2/4. Now this one is quite easy, you can compare it to money. If you were trying to add up a couple of handfuls of money, are you going to convert all 12 of your loonies to quarters in order to add them? No. So why would you do that with the fraction? Now here we're going to add the whole numbers. 7 plus 12 is 19. And then 3 plus 2 is 5 quarters. But you'll notice here we have this 5. 5 over 4, we have an improper. But if you had 4 quarters, you know that's $1. So if we subtract 4, which is what your denominator is, we can add 1 whole. So this becomes 20 1/4. Again, 4 quarters is $1. Often compare it to money and you'll find it makes more sense. Another way to look at this is also compare it to the adding we were doing before. Whenever you added numbers and they equaled more than 10, you did a carryover. Think of that as what you're doing here. Okay, let's do a couple of subtraction. Same idea. Find a common denominator. In this case, it'll be 36. So we'll get 33 over 36 minus 2 and 20 over 36. 6 minus 2 is 4, and 33 minus 20 is 13 over 36. The second example, your common denominator is 20. So we get 18 and 4 over 20 minus 11 and 15 over 20. But before we go any further, you'll notice if I did the 4 minus 15, I'm going to get a negative number. This is going to be a problem. But we can, again, go back to the arithmetic of whole numbers and decimals, and when we did subtraction and we were going to get a negative, we would borrow. And that's what we're going to do here. We're going to borrow from this 18, making the 18 a 17. In order to do that, we add 20 to the numerator. 20 because that's what the denominator was. So 1 whole is equal to 20 20ths. Or if you want to think of money, 1/20th is actually a nickel. So $1 would be 20 nickels. So this becomes 17 and 24 over 20 minus 11 and 15 over 20. 17 minus 11 is 6, and 24 minus 15 is 9 over 20.